Hi everyone, today I'll be talking about 2005 AMC 12B problem 24. All three vertices of an equilateral triangle are on the parabola y equals x squared, and one of its sides has a slope of 2. The x-coordinates of the three vertices have a sum of m over n, where m and n are relatively prime positive integers. What is the value of m plus n? So if we write our points as a squared, b squared, and c squared, we know that the slopes between these points, for example, the slope of if the parabola looks something like this, and the triangle looks something like this. Sorry. It looks something like this because this line would have slope 2. Though this shouldn't be horizontal. Sorry. Anyways, so we know that if this is A, B, and C, the slope of AB, which would be 2, would be equal to a squared minus b squared over a minus b. This is equal to a plus b. And the other slopes can be found similarly. So the slope of AC would be a plus c, and the slope of BC would be b plus c because of difference of squares. So then we have a plus b equals 2, and we want to find a plus c and b plus c. And note that the sum of all of these slopes would just be a plus b plus c over, or 2 times a plus b plus c. And since we want to find all the x-coordinates, which is a plus b plus c, we want to find the sum of all the slopes and then divide it by 2. So now we want to find the slopes of the other two line segments of the triangle. And because a plus b has a slope of 2, we can represent that by the complex number 1 plus 2i, because this line segment from the origin will also have a slope of 2. And to get the slope of AC, we know that AC is just a rotation of 60 degrees from AB. So that would be a multiplying by the complex number I pi over 3, since that's 60 degrees. And this complex number would be cosine pi over 3, so 1/2, plus sine pi over 3, which is root 3 over 2. So we'd get that the slope of AC would be the slope of this complex number, which we can find to be 1 plus 2i times 1 plus I root 3 over 2. So the slope would be so the imaginary part, so root 3 plus 2. And then over 2 over 2 over, and then the real part, so 1 minus 2 root 3. So this is equal to 2 plus root 3 over 1 minus 2 root 3. And that's the slope. And we can do the same procedure to find AB. So we would be multiplying by 120 degrees instead. So 1 plus 2i times e to the 2 pi I over 3. And this would give us a slope of so then the sum of all three slopes would be 2 plus 2 plus root 3 over 1 minus 2 root 3. Yeah. plus negative 2 plus root 3 over negative 2 root 3 minus 1. And now we want to rationalize these two fractions. Or first, add them up anyways. So 2 plus root 3. And the denominator is essentially difference of squares, so it's equal to 12 minus 1, so 11. And then the numerator would be, sorry, I missed something here. This is, sorry, this should be negative 2 plus root 3. Yeah. And let's take care of the numerator by itself. So negative 16. So we have 2 minus 16 over 11, which is equal to 22 minus 16 over 11, which is 6 over 11. And we have to remember to divide this by 2 to get 3 over 11, and then we add the numerator and denominator to get 14, which is answer choice A. Thank you.